When we look for signs of extraterrestrial life anywhere else in the universe, there are a lot of options to consider. It's estimated that there are as many as 100 billion planets in just our galaxy, let alone in any of the billions of other galaxies beyond. So we have to find ways to narrow down the search. One way is to make certain assumptions about life, mainly that it's most likely to exist under conditions that closely or exactly mimic Earth's own. We look for planets, then, that share certain characteristics with our home. Finding planets with water is a crucial aim. But even with our best technology, we still can't precisely see another world's surface features from afar. So how can we know? Generally, scientists first look to see how far away from its home star any planet of interest is, trying to gauge whether it's in the habitable or Goldilocks zone. This is the distance from a star where temperatures and conditions are just about right to form liquid water and host moderate climates. But then again, the habitable zone always varies depending on the star type, its age, and whether or not it's alone or part of a binary system. There are many variables at play. We can appreciate this even with our own sun. While it's fit for Earth right about now, it won't always be. In a billion years or so, as the sun moves towards red giant, Earth will inevitably find itself outside the habitable zone that it currently resides in. How equipped a planet is for harboring life also depends a great deal on the type of star that it's orbiting around. Not all stars are created equal. Some are more massive, some release more radiation, while some live for a lot less time than others. There are 7 types of main sequence star, although there are some other types that branch off too. From the generally hottest to the generally coolest, they're labeled O, B, A, F, G, K, and M stars. Our Sun, as it is a G star, with an average temperature of around 5,800 Kelvin or 10,000 degrees Fahrenheit. It's a relatively rare specific star in the galaxy, as G stars only account for around 7% of all stars. The majority are actually the smaller M-type stars, which live the longest and account for some 80% of the sky's total star content. What's most important for today's question, however, is that Earth just so happens to be in the perfect position for a G-type star, but only for that type of star in particular. If then our star were to change, this world would find itself fundamentally altered too. So how might Earth fare? For example, what if Earth moved around one of the largest stars in the universe instead? Although records do vary, one of the largest ever discovered is named UV Scuti, and it's an absolute giant compared to the Sun. Sitting near the center of the Milky Way galaxy is the constellation Scutum. UY Scuti is about 1,700 times larger than our Sun is. It's so big that it's hard to miss it in the night sky, even from here. And as such, it was discovered early in 1860. It's further classed as a hypergiant star and is the result of either a small K or M-class star reaching the end of its hydrogen fusing phase. Indeed, this is something of a quirk in how the universe works. Some of the largest stars can form out of what were once some of the smallest. If UY Scuti replaced the Sun in our solar system, its surface, or photosphere, would reach all the way past Jupiter, incinerating every planet, including Earth, inside of that range. But what if Earth was instead moved to its habitable zone? Might it survive in its current state if it were possible to just shift space around? Probably not. In general, more massive stars emit much higher levels of UV radiation. So with the likes of UY Scuti, that radiation would be enough to strip Earth's atmosphere fully away, rendering it totally uninhabitable. Right now, it isn't known if UY Scuti, in its current location, has any planets orbiting around it. But scientists are confident that even if it does, none of them will host life. Larger stars just aren't great for life in general. As well as emitting much more harmful radiation, they die far faster than their smaller counterparts do. The best stars for life, then, are generally at the smaller end of the scale. G, like our Sun, or K classifications, or even tiny M stars. So how would Earth be if it orbited a different star, but one such as these? Red dwarfs are the smallest known stars still on the main sequence of their lives. Brown dwarfs are smaller still, but are also a strange case. Technically, they're too small to be stars, but too large to be planets. They're something of a bridge between the two, and are sometimes referred to as failed stars, as they can't host nuclear fusion. Red dwarfs, though, are easily the most common type of star in our galaxy. So actually, in another reality, they're probably the star we'd be most likely to end up around. They can be as small as 1/10 the size of our Sun, however, and can generate temperatures that are thousands of degrees lower, at around 2000 Kelvin or 3140 degrees Fahrenheit. Living around such a star might be possible, but it would be very different and difficult. First off, Earth would have to orbit much closer than it does to our current Sun, or else it would quickly freeze over. But this in itself creates some other issues. For example, red dwarfs are so small that they could tidally lock with Earth, like Earth already does with the Moon, meaning that only one side of the world would ever be facing the star, receiving heat and light. The other would be in perpetual cold and darkness. This would then create an extreme split in living conditions, with a potential sweet spot for life found only on and around the light-to-dark boundary. Not impossible, but definitely uncomfortable. But finally, there are some other, more outwardly unusual stars than just main sequence stars, too. At the end of main sequence, there are other forms, including white dwarfs. Tiny yet extremely dense, one spoonful of a white dwarf's mass would weigh tons. So here, the setup really begins to shift. Interestingly, if a tiny enough white dwarf replaced our Sun, which eventually, as per our Sun's schedule, it really will do, then our orbit wouldn't be affected much. Despite their size, white dwarfs can have about as much mass as the Sun does now, meaning a similar gravitational pull. But the light in the sky would all but disappear, and temperatures would plummet. We would have to be 99% closer to it in order to have even close to habitable conditions then. And at that distance, a year would be about a day and a half. Of course, an alternate outcome for a star more massive than our Sun is that it could collapse into a black hole. In another life, then, could we survive orbiting around one of those? Scientists say maybe, and perhaps even with a little bit of usable energy. Despite generating no heat or light themselves, it's thought that black holes could squeeze and funnel the cosmic microwave background radiation into an alternate heat and light source, to a point. Predominantly, though, darkness would still prevail. While living so close to a black hole could potentially throw up some fun physics, since we'd be traveling so fast around it, we might age at a much different rate. We might be able to find a way to harvest the accretion disk. We could be afforded a severely distorted view of the rest of the universe, thanks to an up-close lensing effect. For now, whether life is possible around any other star is still a matter that's very much up for debate. But it's clear that were Earth to have orbited anything other than the Sun, then things around here would change a lot. Because that's what would happen if Earth had an alien